So now we need a battery model to work with the peak power tracker of SOLO. Shown here is a sketch of typical discharge curves for a lithium-ion battery with 8 series cells and a nominal voltage of 30 volts. The end of discharge voltage is normally around 20 volts for most lithium-ion batteries of this type. You don't want to go below 20 because below 20 you will either damage the battery or severely limit its lifetime. I show 3 curves, 1C, 2C, 3C, just giving you what the discharge would generally look like with this type of battery. Shown here is capacity. I just have it normalized from 0.25 to 1. That would have a time on it also, but in this case I've put no time because we're going to create a SPICE model for this battery, and we have to compress the time for the model to something like on the order of several seconds and not minutes or hours. So I'll go into that shortly. The nominal voltage shown here around 30 volts. It's 29.6 typically. End of discharge, as I said, is 20. This knee right here is normally 26.4 volts or so. That's what you typically see with a lithium-ion battery. It'll go over the edge at 26.4. So you really want to stay in this portion of the curve to operate the battery and to have maximum lifetime. And we'll go through that in a little bit, but this just gives you some typical ideas of how the battery characteristics would look and what we need to incorporate in the model. So let's look at the simulated discharge curve. Here we have an initial voltage of 29.6 volts. We're discharging down to the 26.4 volt knee, and you can see that the capacity in time is 10 seconds. 10 seconds with a 1 amp discharge, that's a 10 amp second capacity battery. We want to keep the operating range on the battery up here in this linear portion of the curve. We want to stay away from the knee. So this is our simulated discharge curve, and up next will be the SPICE model, which is very, very simple to create this curve. So what does the SPICE model look like? Well, it's very, very simple. You can see it here. I have a battery with initial voltage of 29.6 volts. I have some parasitics that are in every battery, some series inductance, the fixed series resistance, and capacity of the cells with a series resistor to simulate the AC. All of this is really for the AC characteristic of a battery. Below I have a behavioral voltage source that works based on the current flowing through the battery and the terminal voltage of the battery. So initially, if the voltage is greater than 26.2 volts where we had the knee, we would just be 0.25 times time times the current to create the drop in the battery, the slope of the discharge. Once you hit that knee, I increase the resistance from 0.25 to 2 to make it even steeper slope. And here's our 1 amp discharge current, so that's how we create this very simple battery model.